Hey guys, Madhav here. This is our end of the Python workshop. Last workshop, we were using Kaggle. Again, you can register here if you haven't already and go to the links in the description. We finished in the last video this first workshop on Python basics, learning about comments, data types, operators, and wrapping up with functions. And now after having done a few cool exercises where we created a, color mood ring in the last video and generating some sounds and creating an emoji generator, we're going to learn the last little bit, which is some more advanced Python components. This notebook, just like the others, is linked in the description, so just, go to the description and then you'll be able to click on a copy and edit button and get started. So let's get to it. Last little bit of Python. I'm going to again, right click on the cells to run code and get the session started. So this time we're going to learn about three features of Python code that make it possible for us to do real coding, conditions, which, add logic that allow you to run some code and not others. We're going to learn about loops that can run code again and again. And finally, classes that let you organize your code, reuse code in a different way, which we'll learn about soon. There is a advanced Python notebook to give you some advanced expert features. I won't go through this, but I will link it in the description so that you can read through on your own. Okay, let's get started. So the first thing is I'm going to throw away this old notebook. We're done with it. And then the next thing is let's get started here. So the first feature is pretty easy. It's pretty intuitive. What we're doing here is, again, we have defined a function. We're receiving a temperature as input. But based on what the temperature is, we will run different lines of code. So if the temperature is greater than 25, then we will run this line of code, which returns a certain string, which you can see over here. It's warm outside is returned when we check temperature at 30 degrees Celsius, and then it gets printed based on the built-in function in Python. If we pass in 20, well, this line of code will run, but 20 is not greater than 25. So we go to this else if statement, which is combined elif. So we go here and then try this, if temp is not greater than 25, maybe else if, temp is greater than 15. 20 is indeed greater than 15, so then this line of code runs and we get a different thing returned. Finally, if none of those lines of code above ran, then this else clause will kick in and run this line of code, let's say at 5 degrees Celsius. So pretty easy or intuitive concept. Just run different lines of code based on which condition is true. Keep in mind you need the semicolon here, and keep in mind you can have as many lines of code as you want as long as you add an extra tab. So we identify lines of code that are supposed to run here based on tabs. So for instance, print, hey, this also runs here. 1 plus 2, 3. So this also runs here. But if I had this, well, now all of this code is not going to run when if when this condition is true. It needs to be indented properly in Python. Okay, setting that aside, let's do something more useful. So we can check if some values exist. This is a practice called data validation. So whenever we first, get some data, we want to check if the data is as we expect, validated. In this case, the way that we're validating these two inputs to this function, which checks if, we have some ingredients in our pantry. So let's say in our pantry, we have bananas, we have apples, and we have cookies. Let's say we also have eggs. So let's say we have a pantry. We pass that in alongside some, thing that we have to check. So the pantry list goes here, and the thing to check goes here. So the first thing we check is, have we been given a pantry? Have we been passed in a list of things that we possess? If not, then we're going to return an error. Or if not, this ingredient, so we haven't passed in an ingredient that we need, then we're also going to return an error. Only if we have the input data as we expect it, it's been validated, then are we going to run our actual function logic, which is if the ingredient we need is in the pantry, i.e. if this piece of text is in the list of pieces of text, then we will return that you have the thing you need, otherwise you need to buy the thing you need. We'll read this over. If it's not making sense, it might take a little bit. One thing to realize is that, an empty string, it doesn't count as having something that we passed in. So actually, not some empty string is actually true, because there is no piece of text here. So yeah, uh, we have not provided an ingredient that we need. Also, none or false or any of these things, they will evaluate to having this condition be true and this code running. So if I run this code, you can see the first thing when I check for eggs, yes, I do have eggs, so this line of code ran. Oops, I need to buy chocolate because there is no chocolate in this list. So we checked this, we did provide a list and some text. We checked this, chocolate was not in the list. So we get to this else condition and we run this. Finally, if we do not provide, this thing, so we do not provide any needed ingredients, or we don't provide a, thing in the pantry in many forms. So it could be like we provide none or false or an empty string. All of these things are called falsy. Like they're like false, they aren't there. They're not valid inputs. Then this line of code will catch that and prevent us from making mistakes. Keep in mind, if we didn't have this, so let's say I comment this out, and instead of an else if, this is just an if, note that these things will break our code, especially this line, because we're trying to check if we have none in none, but like the in operator is expecting we have a list of data, but we don't. So if I run this now, I get an error. That's why validating our inputs, making sure we're operating on what we expect to operate on, is very important. Let's run this again. So there we go. Here's another way of doing it. So if we have some name, something that's valid, then we say, okay, we have a name. Otherwise, we just say, hello, stranger, because they haven't given us a name. So that's if conditions. Let's do a fun little exercise related to if conditions. So last time we generated some sound that we could download and then play. That was pretty cool, but what about creating a magic 8-ball? That thing where you shake it and it gives you a yes, no, maybe answer? Well, this example shows off how we can use some pre-built functions in Python alongside some if conditions in order to create this like fun little app. Take a second, pause this if you need, try it out, and then I'll go through it. Okay, let's do it. So the first thing is I'm being told I need to use this random.randint function that's built into Python to generate a number. Well, if I search this up, it tells me, well, chatbots tell me and the links tell me that to use this function, what I need to do is first off, regular function syntax, put the function name and then parentheses. But also, I need to specify a range of numbers that I can generate. So for a number between 1 and 20, I need to provide 1 and 20. So that's that done. Now I need to fill in the blanks, so I need to check if this random number is less than or equal to something. Well, the only thing that makes sense is that has to also be a number, because I can't, well, I can't check if something that isn't a number is less than or equal to a number. That doesn't make sense. Anyways, what's the point here? Why are we trying to check if the random number is less than or equal to something? Well, keep in mind that this is random. Some percent of the time, it might be, let's say, less than 7. Another percent of the time, it might be, let's say, less than 14. And another percent of the time, it won't be either of those cases. So when I do random number is less than or equal to 7, all of the code that is inside of this block, it will run some percent of the time based on whatever the random number happens to be. And that is some logic that's useful for my magic 8 ball. Because some percent of the time I want to return a positive response, some percent of the time I want to return a neutral response, and finally some percent of the time I want to return a negative response. So I can fill in some blanks, some negative response here. It could be answer unclear. Here, let's say you bet. Um, it's happening. I guarantee it. All right, cool. Finally, the last to do is we want to pick a question that we want to answer. Are people learning Python well in this tutorial? Let's see what the answer is. So I run this piece of code. Again, press here, Control Enter, both work. Run some complicated code. Without a doubt, excellent. The Magic 8 Ball says you guys are definitely learning. Let's say, are people learning Python and enjoying their experience? Let's check this out. It's unclear. Ask again later. All right, let me try again. So let's ask again. Oh, they're not enjoying their experience. Well, that's unfortunate. Okay, that's a cool little way to show off, what can you do with these Python functions and, some conditional logic. Next up, let's learn about another feature of Python, which is loops. They help us repeat lines of code. So let's say I want to count to 5. One way to do it is I could do, print 1, print 2, print 3, print 4, print 5. I think you'll agree with me, if I want to count to 100, this is very annoying. So Python has this useful thing, it's called loops. For loops, they count a specific number of times, and this syntax might seem weird. Well, I'm going to show you what it does first by just running it. So let's say I run this syntax. What I'm telling you is I will start at 1, and then it will go to 2 and 3 and 4 and 5, and then stop just before it gets to 6. And on each iteration, whatever lines are indented inside of this for loop, they will execute for each value of I. If I run this, well, you can see, okay, that's what's happening. But why? Why is it happening like this? Well, here's the thing. So another way that I could do this is I could create a list. So up to 5 is equal to 1, 2, 3, 4, 5. Then I could do for I, so for num in up to 5. So for each number in this list, print the num. If I run this, you can see 1, 2, 3, 4, 5. Why does this work? Well, for num in, so for each element, each item inside this list, the for loop will execute. So whatever lines of code are inside the for loop, like let's say print num times 2 or print num times num, all of those lines of code will execute on each iteration. So that's how for loops work in Python. You have to provide some kind of thing that you can iterate over. Now, the standard thing here, this range function, it takes in some inputs and then automatically generates a list like this. So for example, if I try and convert a range to a list and then print it, you can see, well, I am getting back exactly what I expect. For instance, let's say I wanted to change my list, it would be inconvenient like this. But like this, very easy. I could simply say go up to 10, well, not up to 10, up to 9, so stop at 10. Because just by changing the inputs to the range function, I can, generate a new list. Over here, I'm doing the same thing, but keep in mind that the range function, if you don't include a starting number, it's implicitly 0. So if that's fine by you, you can go right ahead with it, and you can check out this code that maps to this output. Finally, just like with list indexing, you can have a step size. So if I do, let's say print range 1 to 10, or let's say 11, you got to convert it to a list if you want to see a nice output. So you'll see this. If I do a step size of 2, what's going to happen is it's going to start at 1, but instead of adding 1 to get to the next number, it's going to add 2. So I'm going to start at 1, add 2 and get to 3, and then add 2 again, get to 5, add 2 again, get to 7, add 2 again, get to 9, and so on. So this is all the odd numbers. If we do the same thing with 2, well, we're starting at 2, adding 2, 2, 2, and we get the odd numbers. So range is a good way to generate some lists. Anyways, here I'm using range in that way to generate, the right list of numbers to iterate over so that I only get odd numbers. Hopefully that shows you how for loops work. Keep in mind, just like I said, for loops can iterate over any type of list as well. So for example, before I had a list of numbers, now I can have a list of text. Let's say I want to go over fruit and fruits, and I just, list the items. So I can do apple, banana, cherry, because I can go through each of these items one at a time at each iteration of this for loop. Finally, there's this cool function called enumerate. Just so you see what it does, it's like the range function. I printed it out, and you can see it's taking my list, apple, banana, cherry, and it's just adding, numbers to each item in the list. So when it does that, I can go over each number, which I'm calling an index, and each fruit. So each item in the list now will be, index 0, and fruit apple, index 1, and fruit banana, and so on. And then I can use these two pieces of information to print out a numbered bullet point for each item in the list. If you want to take a moment, pause, review this. The last thing to note is that with for loops, I always know how many loop iterations there will be based on the length of the list or, whatever bounds I set in the range. There is another type of loop called a while loop. So what's going on here is while loops keep running for however many iterations are true based on some condition. So we have some variable current. While it's greater than 0, we have a print statement, and then we always subtract away 1. However, sometimes, based on a random number, we might undo that subtraction. We might add on 1, or we might add on 0, don't do anything. Because of this random line, we don't know how many times this loop is going to run. So if I run it once, you can see I had, however many iterations, where you can see with these repeated 3s, I was adding back 1 so that it canceled out with this -1. You can see here the number of items changed. Here we got a shorter number of items, shorter still, longer, and so on. So that's what while loops are good for, when you don't know how many times you want to repeat some code, but always want to do it while some condition is true. That just about wraps up our, section on loops. There is a there is an exercise here that combines this idea of loops and if conditions, but it's not visual. So why don't we hop over to an exercise here instead? Let's try the spiral art generator. So the first to do, again, I'm going to stop here, pause if you want to go through it, just, take note of the to-dos and try doing this. Okay, I'm assuming you've tried. Let's do it together now. So first thing, we have to set some parameters. So this is just assigning some variables. We learned how to do that. Let's try 1000 points. How tight it is. I want a value between 0.1 to 0.5. Let's try 0.4. And the color speed, let's try 0.02. That's the instructions we were given. Next, it wants us to iterate from 0 to num points minus 1. Keep in mind, this is a variable, but it doesn't matter. We know how we can iterate over a fixed number of times in Python. We can use a for loop over a range. The default start is 0, so we don't need a default starting point. But the endpoint we do need. We do need an endpoint of num points minus 1. We don't exactly know what num points is until we set it, but you can imagine 1000 minus 1. I could type in 999. So it's the same thing if we have variables here. Next, there's some fancy trigonometry. It has a to-do over here. It says add x and y coordinates to these lists. We know how to add things to lists. We do xcoords.append the x and ycoords.append y. Next, it says use this dict to choose a definition for a type of spiral. I'm going to start with tornado. Ah, never mind, that's not an option. I'm jumping forward in exercise. I'm going to start with rainbow. Alright, finally we run it and we run some fancy code and we get some fancy spiral arts. That's kind of cool. Let's say we want some different colors. We can try maybe sunset colors. So this is currently a rainbow. Let's see if we can get warm colors only and run this. Yeah, so different colors. Let's try ocean colors, so blues and greens. Plus, I will change the spiral tightness. Let's make it very loose. And I want the colors to change very, very fast. So I'll make this 0.1. And let's make this a lot more dense. So run that and run this. Yeah, that's a lot more dense. Cool. So that's a fancy spiral generator. Kind of cool application of for loops. If you want, try this exercise out as well. I think it's a cool use of combining if statements and for loops. Pause it, and we'll go through it together. Okay, assuming you've tried it. First thing, we have a function to do. It wants us to map an integer score to a string, and it says, these numbers, they convert to those ranges. So I can simply, if, let's say, score is greater than or equal to 90, I can return an A and then keep repeating. So if score is greater than or equal to 80 and score is less than 90, we can return AB. Now keep in mind, this part, although it corresponds well to this range, it's kind of redundant because, we already checked if the score is greater than or equal to 90. Well, if it's not, only then would we come here. And if we already know that the score is not greater than or equal to 90, it must be that the score is less than 90. So we kind of don't need to check this. But you could, it wouldn't change anything, just less efficient code. Okay, else if the score is greater than or equal to 70, we want to return a C. Else if the score is greater than or equal to 60, return a D. And finally, for anything less than 60, we're told to return an F. Oh, F. All right, so that's that done. Next, we need to process a list of student scores and display their grades. We're receiving a dictionary that looks like this. So it maps a student's name to their school. So to do, look through the dictionary and for each student print their name, score, and letter grade. We can get the letter grade by using the above function. Cool. It says hints, check out the below methods that help you access dict data. Well, why don't we take a look? So I can change this here and dict keys. It gives me the keys of the dictionary. So, what are the actual names of the students? The values gives me the scores, and the items, it combines the keys with the values. That seems to be useful to me. Okay, so I'm pressing Control and slash, forward slash. It's next to your Shift key to comment everything in and out. All right, so why don't we do a for loop while we use this items list where I can access both the names and the scores because those are two of the things that I need. Okay, so I'm going to do for name score in what we see here, student scores dot items. So that will make me iterate over each name and score one at a time, which is what I'm hoping to do. It says print the name. Okay, so I'm gonna print name. Oh, I can't use a colon. I need to combine some things together. So I can do print name plus name. I can do a score. I can use a f string to save some time. So I'm gonna do score. Finally, I need a letter grade. Well, luckily I just created this function that converts scores to letter grades. So I can do print f grade, and then I want this function, which is calculate letter grade based on the score. I can put all of this inside braces. Whatever the function returns will be converted to a string because of this f string syntax. So that's that. This information looks a little bit much to me. So what I'm just going to do is combine it all on one line. And the name of the student is the name. Okay, so now all of the info is on one line. Okay, great, that looks better. And it also says calculate and print the class average. And to use the average function, I don't actually think there is an average function built into Python as standard. So what we're going to do instead is we're going to have a manual average. So the total score is at the start 0. For each student, we add on to the total score. So total score equals total plus score. Python also lets you do this. These two lines do the same thing. Anyways, after we've done that, we need to divide by the number of students. Well, we can get the number by just counting how many, let's say, keys in the dictionary. So how many names in the dictionary. So the average is equal to the total divided by the length of this. So then remember, this returns a list of the names, the keys in the dictionary. Finally, we can print a string class average is going to be average. And we can even put that into a grade if we want. So calculate letter grade based on the average. We print that out and we can see the class average is 82.6 and the grade is a B. Anyways, cool application showing off how we can create different functions, how we can reuse functions within other functions, how we can combine the idea of for loops and if conditions. So this is very good test of your knowledge. The last thing to talk about, and then we're finally done, I promise, we need to talk about how we can work with classes. Now, classes are a complicated idea. When I first learned about classes, it took me a long time to figure it out. So I'm going to try and explain it simply with this analogy. Classes, they are like templates, blueprints that we can reuse to create something over time. So a class is like this cookie cutter. You press it into the dough and it will create multiple objects, which are these multiple cookies. Each object can have attributes added on top of it, such that you have both objects, both of these cookies, created from the same class or same blueprint or same template, which is this cookie cutter. But we can add customized attributes like these, sprinkles or decorations or whatnot to one cookie and not the other. So this allows us to reuse the cookie cutter to create multiple cookies that look different instead of, let's say, trying to shape out, a star shape every time and then add on these, little decorations. It's much more efficient to reuse the general class instead. So that's, nice and all. Let's take a look at the code version of this. So here I have a class. It takes some name. I can define some attribute, so a variable that every object created by the class, every instance or every copy of the class, everything created with that blueprint is going to have. I can also have a special function, so it's called a method, but it's just a function that every one of these classes will have. So again, this is a blueprint. I can call the blueprint like this as if I were calling a function, but remember, it returns an object, not like, some value that is like a regular function. It returns an object. Under the hood, actually, this is more like a regular function than you'd believe, but whatever. Let's skip the complexities for now. Anyways, you can see just like I'm creating multiple cookies with this cookie cutter, this class, I'm creating two cookies, two objects. I can create multiple dogs that both, share the same code. They have the same species, this variable, and they both have this bark function or method. So I can call bark on both, and it says, woof, I am one of these species. Now, the other thing I mentioned was you don't have to create, exactly the same objects. Here, I just stored the objects in different variables, but there's no difference in the blueprints between them. You can indeed customize objects a little bit. So, add those attributes or those sparkles to one object and not the other. So here's a more fancy dog class where we have what we call a constructor. A constructor is a special function that automatically gets called when creating an instance. Or, instance is another name for an object. I know it's confusing. It was confusing for me too. Anyways, this constructor is what I was talking about earlier. I said, oh, this is a little bit like a function. Well, it kind of is because when you're doing this, when you call this code, a special function, the constructor function gets called, where you can take in any input you want, like the name or the age of the dog, and then assign it to private variables. So these are instance attributes, they only belong to that object itself, as opposed to this class attribute, which you saw was shared by Charlie and Diego. I even customized the bark method so that each dog now will have a different name saying woof. So this is all very complicated, I know, but the key idea is simple. We have one blueprint, this class. It has a bunch of features that are mostly shared between the different, objects, the cookies that we create from that cookie cutter. But there are a few attributes like the name of each dog or the age of each dog that we can personalize to make one cookie have, special decorations while another cookie has different decorations. So for example, we create Buddy the dog here with a unique name and age, and we create Max the dog here with a unique name and age. And now when I print, how Buddy says woof versus Max says woof, because these are different objects created from the shared blueprint, the shared class, when I set these instances, these instance attributes, the private, the self-owned data, they're going to have different, outputs because of the way I defined the Bach method. So the overall message here is that classes, they're like templates, cookie cutters that can let you reuse code, and you can define special constructors to change the different attributes among different instances, different objects. Also, you can define shared methods that can make use of these differences to do unique things. Hopefully that makes sense. If not, take a second, pause, think through this code, ask some questions to ChatGPT, because I'm going to make things more complicated now. So the more complicated part of classes is that here, you see one cookie cutter. It's like one blueprint for one cookie. Blueprints in general get more complicated, don't they? Like imagine, creating a blueprint for a building. Yeah, you have the overall, building blueprint, but then you also have blueprints for different rooms within the building. You even have blueprints for, let's say, the IKEA furniture that needs to be assembled within each room. So there are layers of blueprints. In the same way, we can have layers of classes where one class can, take some context from another class, just like, the way that you design the blueprint for one room will be shaped by how the building layout is as a whole. For instance, if you have the room near the edge of a building and the building layout has windows in it, then that will influence the way that you design the room. Anyways, we call this idea inheritance, where one class, one blueprint, is influenced by another. So let's say I have an animal class, fairly bare bones. Each animal, it has a constructor that can take a name, because all animals have names. And also all animals sleep, so there's a sleep method. However, let's say I have a particular animal, a cat. We use this syntax to say that cat is like, one level down from animal. It's what we call a child class. It inherits these constructors and methods from the animal when we call this. And this is just what we call boilerplate code. You just have to remember it and always do it. So super refers to this, class above a cat because cat inherits from animal. Anyways, what's so special about a cat? Well, it has one special, instance attribute here, one special variable, and it has a method. So any old animal, it does not have a meow method, but a cat does because it is a cat. However, a cat also will have a sleep method because it is an animal and all animals have sleep methods. Similarly, I have a dog here. Here you can see that, a dog has a special fur color instance attribute, and it also has a bark method, which isn't available to cats. So for example, I can create Whiskers the cat, which is an indoors cat, and Rex the dog, who has golden fur. If I put whiskers.meow, it works. If I do whiskers.sleep, it works. But keep in mind, there's no sleep method here. The only way that I'm accessing the sleep method is because I was able to inherit from another class. So I was able to get the sleep method from the parent class. Similarly, Rex can bark and Rex can sleep because Rex is inheriting from the superclass, which is listed to be animal, which does have a sleep method. Keep in mind, if I try rex.meow, it won't work because I said Rex is a dog. And, a dog doesn't have a meow method, and neither does its superclass, which is an animal. So that will not work. Says dog example has no attribute meow, so it's explaining why it's not working. Here's a list of the key things we talked about. If this seems abstract, I'm going to try one last time to explain it, but I understand it's kind of hard. Here's an example of how we might use classes in any e-commerce software, something, practical. We could create a user class in our e-commerce software, and every user has an email, a password, and a login and logout method. But we can create a subclass, just like, we created a cat subclass of animal, we can create a subclass here. So we can create a subclass, which is a customer, and a customer also has a cart attribute, which is a list of products. Products being some other class, actually. It's not like, a built-in thing in Python. You can't just have products. But once you define a class, you can have cats and dogs. So once you define these classes, it's like you created a data type. That's another way to think about classes. They are complicated. Anyways, everyone's a user, everyone has email, password, login, logout, but customers also have a cart, which have a list of products. They also have orders, which is a list of orders, and they have these two special functions, add to cart and place order. Admins, however, they don't have that because they're not ordering things, they're not the customers. So they have some permissions. They have these special functions that they can use to manage users and get analytics data or modify which products are available. Now, a customer can also be split further up, you can have subclasses of this subclass of the base class, the parent class. So there can be premium customers that have, a certain membership level. They get like a discount rate, which is a, decimal percentage discount. They can have an applied discount function or access VIP products function. So they have special functions that normal customers don't have. And those can be different than, what guest customers have if they're only, just checking in and out once. So oftentimes, this approach is called object-oriented programming because, again, every time we create a copy using a class, we call it an object. So object-oriented programming is about define, the things that you need, define the objects, the classes that you need, create classes, and then create subclasses and so on so that the parent class has the pieces of code, the variables and methods and functions that every object is going to share, and then create more specialized objects for specific niche cases. But at all points, you're trying to reuse, you know, the attributes and the methods available. This is a bit much. This is admittedly a bit much, so let's do a little bit of a fun exercise, and then I can leave you with the less fun exercise for you to try on your own. There are solutions. So let's do one last fun exercise, which is we're going to generate a 3D sculpture. Again, I run this code. By the way, all of these things, whenever we're importing stuff, Python, we now know about classes, right? These things are classes. So there are these Python libraries, just like we were able to download software for a command line, we can download libraries full of Python code. The Python code is a class. So this Go class is something, well, this graph objects class is something, this express class is something, and so on and so on. So we can import classes that people have defined for us with, useful methods and, attributes and stuff like that, and we can reuse their code. If you're looking for where to find code, you can go to PyPy, the Python package index. I have explained this in the past, but you can find different libraries here. For example, the Plotly library that we're gonna be using here. You can find it as a way to create interactive animations. This looks cool, so let's see what we'll do. So what we're doing here is we're completing a class to create 3D data sculptures. Cool. Let's fill out the to-dos. Actually, take a second, go through it, fill out the to-dos, then I'll help you out. Okay, assuming you've had a go. So first we need to set some attributes called .name and .numPoints. That's easy. Self.name equals name, self.numPoints equals numPoints. Remember, we're doing this inside the constructor, which has this reserved, method name underscore underscore init underscore underscore. Next up, what are we doing? It says update some settings, give my sculpture a name. I don't know. Mother's sculpture. num points. Let's say 1,000 points and some pattern. Well, now I can put in tornado. It says init your sculpture and call the right method to generate points. Well, if I look here, the init, I need to pass in a name and num points in order to do so. So my class is called data sculpture. So I put in the class name, data sculpture, and then I pass in, the name and the num points because that's what my constructor expects here. Next, there's only one method, generate points. It expects a pattern type, so that's what I need. So my sculpture dot generate underscore points is the method I'll call, and the pattern type is a tornado. So that's that. If I then run some fancy code, which you are now in a better place to understand, you can see, something, something, calling a function, it's part of a class, something, something. Yeah, it's complicated, but, more and more understandable. Eventually, you'll get, this interactive 3D sculpture. Kind of cool. That's a tornado. Let's try something else. Let's try a helix and run this. Cool. That's a helix. Finally, last one, let's try a wave. Why don't we try a wave? Looks like a bunch of spaghetti, but from the right angle, like this, looks a little bit like a, sine wave. Okay, cool. So that's where I'm going to leave off for today. If you had trouble with classes, review this section. They're very important to understand because, every library that you use ever is going to have classes, so you need to understand them. There is an exercise here that has you create, a few methods for a class. It's a little bit more practical, so encourage you to try that, and there are solutions listed. Finally, there is a more advanced notebook on writing better Python code. So if you want to have a go with this, I'll link it in the description, but you don't strictly need it for our workshops. That's the end of Python, and in the next workshop, we're going to actually get started with machine learning libraries like pandas and LangChain.